Welcome. In this video, I want to see how we can find the slope and equation of the tangent line to a given curve. Okay, we are basically looking at the application of calculus, and to be specific, in this video we are applying differentiation. Okay, so the question that we want to look at in this video is find the slope and the equation of the tangent line to the graph f of x is equal to 2x plus 1 over square root of x at the point 1, 3. Okay, so now calculus, when you look at calculus, deals with changing quantities. So if I have a curve like this one, okay, that is the y-axis, this is the x-axis, you realize that the slope of this particular curve is changing at any particular value of x. At any moment in time, at any values of x, the slope is changing. So if I want to predict the slope at this point, first I have to find what we call the gradient function. Now you find the gradient function by differentiating this particular curve, so that when you find that particular gradient function, you'll be able to predict the value or the gradient or the slope at this point at any value x. Now, the slope at this point is also equal to the slope of the tangent at that particular point. So if this is the tangent, then the slope at this particular point is equal to the slope of the tangent. So here the point that we are looking at is 1, 3, which is basically somewhere here. So first we need to find the gradient function for the given curve. So the curve that we are given is this. So for us to find the gradient of that particular tangent, which is somewhere here, okay, if this is the tangent, we have to find first the gradient function. So to find the gradient function, you differentiate the given function. So I'm going to differentiate or find the derivative. So the function that I'm given is f of x is equal to 2x plus 1 over square root of x. Now, I need to differentiate this one, but for me to differentiate, I have to make this one in a format that is conducive for me to find the derivative. But remember, we are adding these two functions, so I'm going to use some rule, meaning the derivative of this function will be derivative of this one plus derivative of that one. So let me change this one in a format that will be very conducive for me to work out. Okay, now we know that square root means 1 over 2. Again, using the negative index, I can take this one up there. So this will be x plus, if I change this one, it will be x to the power 1 over 2. But because it was down here, I've taken it up, it will be to the power negative that. Then I can find the derivative. So the derivative, which is f prime of x, is equal to, I differentiate this one, again I differentiate that one. So the derivative of this one will be 2 plus derivative of this one, it will be minus 1 over 2, then x to the power, this one minus 1. Okay, the power will reduce by 1. So this power, it has to reduce by 1. And if I try to reduce this by 1, I'm going to end up having this. Now I can simplify. This will be equal to 2 minus 1 over 2, then x to the power minus 3 over 2. Again, I can take this one down so that I have something that looks like this. So this will be 2 minus 1 over 2. Remember, this will be the square root or the second root of x to the power 3 if we use the rules of indices. So this will be x, square root of x, then the answer that we get to the power 3. Remember, when you have the negative index there, when you introduce a positive, you get the reciprocal, meaning this one will go down. It is going to be something like this. So now this is the gradient function. So this gradient function will help me to predict the gradient at any particular point of x. Now when you look at the point, the coordinates that we are given, these coordinates are named in terms of x and y value. So this is the x number and this is the y number. Okay, so now for us to find the actual value or to find the gradient at this point where x is equal to 1, we need to replace 1 in the gradient function. Remember that gradient function will just be helping you to predict the gradient at any point of x. So here we want to predict the gradient at x is equal to 1. So in this particular gradient function, whenever there is x, I'm going to put 1 so that I can find the gradient at this point. Now that gradient will be the gradient of the curve, which is at that particular point, which is also equal to the gradient of the tangent at that particular point of tangents, or the gradient of this particular tangent, because you know that any straight line will have a constant slope. Okay, so the gradient of this particular equation at this point is equal to the gradient of the tangent. So I'm going to replace whenever there is x, I put 1. So I'll come here. So f at the point 1 will be equal to 2 minus 1 over 2. Then we have the square root of 1 to the power 3. So when we manipulate, this will be 1, so we are going to have 2, 1 over 2. Then when we try to subtract this, we are going to have 3 over 2. Okay? So this will be the gradient of the slope at this particular point. Now, apart from finding this particular gradient, which we call the slope, we also need to find the equation of the tangent at this particular point. Now that we know the gradient of the tangent, we can find the equation using one-point gradient form. We know the gradient and we know the point of the tangent, so we can find the equation. So using the one-point form, gradient one-point form, we can say y minus y1 is equal to m x minus x1, where this is gradient and these are the ordinates from the coordinates that we are given. So the points that we are given, you can name this x1 and y1. So these parameters will be variables. We are not going to replace this one and that one. We only replace here and there and the gradient, which we know to be this one. So this would be y minus y1 is this one, the y ordinate. Then gradient is 3 over 2. Then we have x minus x1 is this particular one here. Here I can multiply throughout with 2 so that I can eliminate this one. I'm going to have 2y minus 3 is equal to 3x minus 1. Then at this point I can open the brackets. This multiplied by that, I will have 2y minus 6 is equal to 3x minus 3. So I can take this one this side and that one that side. I will do it by what we call additive inverse. Here I'll put plus 6 and there I'll put plus 6. Here I'll put minus 3x, then minus 3x. But for simplicity, we just say this goes that side, but there are no such things. So this will be equal to minus 3, then this one will be plus 6. So we are going to have 2y minus 3x is equal to 3. And this will be the equation of the tangent. So now, in this question, we wanted to find the slope of the tangent at this particular point of the curve that we were given. Now, every time you are given to find the slope of the tangent at a given point to a curve, the first thing that you need to do is find the gradient function. In that particular gradient function, you have to replace the value for x, if it is an explicit equation like this one. But if it is an implicit equation, wherever there will be x and y, you are going to put these two values and find the value for gradient. After you do that, the gradient at that point, which is this one, is equal to the gradient of the tangent. So using this point and the gradient that you've calculated, you're going to use gradient one point form, which is this equation, to find the equation of the tangent. So for this and more videos, subscribe to this YouTube channel, and thank you for watching.